This video is about how to sketch graph of inverse functions. First of all, let's make some concept of inverse function clear. Do all the functions have inverse functions? Answer is no. Only one-to-one functions have inverse function. So how you decide one function is a one-to-one function? We use a horizontal line test. No horizontal line intersects its graph more than once. We call this is a one-to-one function. For example, look at the first graph. We know this is an absolute value function. When we draw horizontal line, intersect graph twice. So it's not one-to-one function. For second graph, when we draw any horizontal line, pass through the graph only once. This is a one-to-one function. For third graph, this is a quadratic function. When we draw horizontal line, intersect the graph twice. So it's not one-to-one function. Last graph, when we draw any horizontal line, intersect the graph only once. So we see this is a one-to-one function. Remember, only one-to-one function have an inverse function. Then what's the inverse of coordinate 2, -3? We got to switch that. That's a -3, 2. So for inverse of coordinate x, y, the inverse will be y, x. In other words, we know all x means domain and all y means range. Domain of f means range of inverse. This is the same. And the range of original function will be the domain of inverse function. In other words, domain and range switch for original function and inverse function. Question 3. How do you find the inverse of a graph? We know any one-to-one function and its inverse function will reflect across y equals x line. Now let's do some practice how to sketch the inverse function of a given graph. First of all, we know that the graph will be reflect across the y equals x line. So you need to draw y equals x first. Intersect y equals x, this point will stay. Then, if it's easy for you to get coordinates on the original graph, like this is the one, is 0, 2. Then you can just switch 0, 2 to 2, 0. So find the 2, 0 is here. We know that 2 points determines a line. Therefore, I just connect these 2 points. You will get, this will be the inverse function. If we call this is a f of x, and the green one will be inverse of fx. Now let's go to the second graph. We still need to sketch the inverse function of a given graph. Still, first step, you have to sketch y equals x. We got the y equals x graph now. Then the intersection of the given graph and y equals x will stay. So this point will stay and this point will stay. Then second, try to find the integer coordinates so we can switch like this point. That is 4 and 3. So we got 4, 3. We switch into 3, 4 now. Find the 3, 4. It's here. The points between this 0, 0 and this point, there's no integer coordinates. Therefore, you can choose any points here. You got to do perpendicular line. And make sure you have the same distance. In other words, when you have this is y equals x, for example, you have a point here. How to find the reflected points across y equals x? You have to, from these points, draw the perpendicular line passing through y equals x. Then the same distance. This will be the reflected points across y equals x. So try to get the same distance over here. Then we got these 4 points already. Then just connect that like here. And this will be the inverse function. This is the original function. Try to get integer coordinates as many as we can. Then if we cannot find, we use this strategy to get reflected points across y equals x. Let's go to next question. Sketch the inverse function of the given graph. We could see this is an exponential function. So there is a horizontal asymptote line. Y equals 0. So for inverse function, there will be a vertical asymptote line. That will be x equals 0. Then we need to draw y equals x. So this is the line y equals x. Try to get some points on the graph. We have this one, 0, 1. For inverse, the point will be 1, 0. It's here. 2, 4. So we have a 4, 2 for inverse. It's here. Then for this point, we will draw the perpendicular line over y equals x. The same distance. This is a perpendicular line. same distance is here. Then we connect these 3 points. Remember, for inverse function, we have a vertical asymptote line. So do not cross this vertical asymptote line. The graph will be like this.